Isover presents the Climova duct system, an innovative installation system for self-supporting air ducts based on the use of Climova boards. Climova ducts have many advantages in terms of installation and product performance. They can be adapted to large and small jobs both off-site and on-site, allowing on-site modifications if required. Climova duct systems are easier to make than traditional sheet metal ducts, and their lightness and strength ensures easy assembly and transportation. Acoustic and thermal performances are also ensured in a unique operation and provide better results than traditional systems. Climova are high-density glass wool duct boards used for the installation of self-supporting air ducts. Climova boards are rigid glass wool boards which are 3 meters long and 1.19 meters wide and have a thickness of 25 millimeters. The boards are lined on both sides with a reinforced aluminium foil on the outside of the duct and glass tissue, aluminium or glass fabric on the airstream side. Cutting guidelines are present on the outside surface of the straight duct to aid manufacture of the duct assemblies. For ease of assembly, Climova ducts are shiplapped. A unique male-female edge design allows precision airtight ducts to be formed. Note that the male shiplap also has a foil overlap on the outside face, guaranteeing a better joint between the Climova boards. To build an air duct network using the Climova system, straight ducts and duct assemblies fitted using Climova tools, which ensure a neat cut with a suitable regulation of the cutting knives. Climova tools can be classified in two groups. Climova MM tools are used to make the cut grooving in duct boards, and Climova MTR tools are used to cut straight ducts and transform them into duct assemblies. Climova MM tools have been especially developed for cutting the inner lining of Climova duct boards and are fitted with high quality and easy to replace steel blades. The Climova MM tools are used to produce cut grooves with a chair-shaped profile, which allow the duct boards to be folded at an angle of 90 degrees. This produces all the joints from a single piece of board. The glass wool is removed by hand as the groove is made. The red label tool makes longitudinal grooves on the board with a modified chair-shaped profile, allowing the duct boards to be folded at an angle of 90 degrees. The blue label tool is used to make longitudinal grooves on the board, leaving a flap for the final joint of the duct. The black label tool makes shiplap edges to enable the union of single pieces or assemblies. The white label tool has a set of blades at an angle of 90 degrees as regards the surface to be cut. It is used to cut straight ducts for transformation into duct assemblies, following the guidelines on the outside of the Climova. The yellow label tool has a set of blades set at an angle of 22.5 degrees as regards the vertical. It is used to cut straight ducts for transformation into duct assemblies, following the guidelines on the outside of Climova. Climova glue is an acrylic resin-based adhesive. Especially designed for glass wool applications, it is odorless, non-toxic and non-flammable. It is supplied in 1 liter bottles and is used to internally seal duct assemblies such as elbows. The Climova square ruler is made of aluminium and can be set at predefined angles, 45 degrees and 90 degrees. The Climova square ruler makes the assembly of straight ducts from a flat duct board extremely easy, as it is calibrated to allow the duct's dimensions to be measured along the bottom of the duct board. The Climova tape is a 50 micron thick and 65 millimeters wide aluminium tape. It is used in the longitudinal joints to seal the overlap and obtain straight ducts, and also in the transversal joints between two straight ducts. The word Climova is printed on the tape as a quality reference. The Climova stapler is used to primarily fix the aluminium foil overlaps before taping. The Climova spatula is a flexible plastic spatula that is used to remove air bubbles from the adhesion of the Climova tape to the duct board surface. The spatula is firmly drawn across the tape in the same direction to create the best possible adhesion. This is achieved when the lining reinforcement is seen through the tape. The double-edged Climova knife has two different applications. The sharp edge is used to cut through the board, and the blunt edge is used to remove any remnants of glass wool from newly created foil overlaps. Straight duct. The easiest and quickest duct assemblies to produce are straight rectangular ducts. Every cut must start from the male shiplapped edge of the duct board and work towards the female shiplapped edge. Climova tools and Climova square ruler make the manufacture of these ducts much simpler because the duct board does not need any guidelines written or masked on the duct board surface. The Climova square ruler is actually used as the cutting guide. The red tool is used 3 times and the final cut is made with the blue tool. Seal the joints in straight ducts. Precision joints and the unique sealed edge design means low leakage rates, with the associated energy savings in finished assemblies. Glass wool density at the shiplap is very high, giving a more rigid union which improves the assembly. It is not necessary to tape internal longitudinal unions because the folding operation closes the duct perfectly. If the tape is applied internally, it could detach and cause noise due to vibration. Connection to air unit. The outlet connecting the air conditioning equipment to the ducts is one of the most critical points in the installation due to its air speed, which is at its maximum at this point, and also due to the fact that normally there is little free space available at this stage. There are different methods for connecting the main duct to the air conditioning unit. Nevertheless, it will always be necessary to use the profile Diffuser H and screws to ensure that the connection is safe. Finally, depending on the relative position of the equipment clamp and the air duct, it may be necessary to fit a sheet metal angle to reinforce the connection. An elbow is used to change the direction in an airflow network without dividing the airflow in two. A straight duct is made, a cutting point is chosen, the subsequent cut will follow the cutting guidelines, which are an integral part of the outer surface of the Climova board. The 22.5 degrees cut is made with the white label tool. Cuts made at a 90 degrees angle to the board are made by the yellow label tool. One of the pieces made will be rotated 180 degrees to create the elbow. There is no male shiplap and female shiplap end to these pieces, and therefore no flap through which the pieces can be stapled. A bead of Climova glue is applied along all the rims to join the two pieces and to close the inner surface of the duct. After joining the pieces, the Climova adhesive tape is applied and any excess glue cleaned off using the Climova spatula. The elbow can then be placed in the duct network. Connection to a diffuser or flexible duct. Create a Diffuser H frame as already described and a straight duct with dimensions equal to the distance between the ceiling and the duct surface. The straight duct only needs to be connected to the main air duct and taped to ensure air tightness. If a flexible duct is to be made, the process is similar to the previous one. However, a circular cut has to be made on the main duct using a spigot with the same dimensions as the inserted sleeve. Constructing an access hatch. In order to construct an access hatch, a window must be cut out of a straight duct with the Climova knife. A frame must be placed in this window. The frame is made using the Diffuser H profile. The hatch is closed with Climova and then fixed externally with tape on the access door to guarantee the air tightness of the door. Reductions are very common in ductwork systems. Reductions are defined as changes in the size of the duct cross-sectional area and are used to alter the airflow direction and speed. Reductions are the only kind of duct fittings that should be made using the flat pieces method. There are different kinds of reductions depending on the number of sides to be reduced, 1, 2, 3 or 4 sides, and the axis of the two entrances, centered or off-center. The following aspects common to the manufacture of the reductions should be considered. The straight part of the reduction, called dimension X, must be taken into account and must be a minimum of 10 centimeters in size. This ensures a suitable amount of Climova material on which the main duct leading to the final reduction can be fixed. It is better if the reduction is as long as possible, in order to avoid sudden impacts with the airflow. If the reduction is to propel the airflow, then the reduction must be made from the male side. If the opposite case is required, it must be made from the female side. When possible, start with a flat piece, which provides a good guide from which to construct the reduction. All sides which are folded must have transversal cuts with closed angles, clefts. Try to avoid leaving open cuts that may weaken the duct board. When bending the flat pieces, an inner angled cut, cleft, with a dimension of X is made and bent into place. It should always be on the side of the module. Similarly, another cut is made on the outer edge of the module, also with dimension X. Sometimes a sudden change in direction or in the duct section makes it necessary to cut segments, bevel cuts on the duct board. All clefts and cuts must always be glued or taped. Offsets are necessary in order to change the direction of the duct or to avoid obstacles in any way. The duct has the same size cross-section along its length, and its construction is very similar to that of the elbow. The only difference being that the guidelines, with an angle of 22.5 degrees, will be parallel. One of them will be rotated. Branches are duct assemblies that divide a single airflow into separate airflows. Double branches split the airflow into two within the ductwork, whereby the direction of one, a single ramification or R branch, or both, double ramification or trouser branch, of the circulating airflows can be changed. Note that the main branch will have the biggest proportion of any airflow within it. Shoe. This kind of branch is generally not recommended, but it can be useful for connections to diffusers, grids or other elements, and is a quick and simple method. In this case, the branch has a lower height than the main duct. Firstly, a line must be drawn at 22.5 degrees, following the guidelines on the main duct, as in the case of the elbow. Then another line is drawn at 45 degrees, with a minimum separation from the previous line of 10 centimeters. The cuts are made with the MTR tools, obtaining 3 pieces which are sealed with Climova glue and taped with Climova tape. The Diffuser H profile is placed on the main duct. The branch is then added and inserted into the main duct to create a friction fit connection with the Diffuser H. The branch cannot pass inside the main duct as the Diffuser H has a lip on the inside. Finally, Climova tape is applied along the perimeter of the branch and the Diffuser H. Simple dynamic or R branch. It is made from a straight duct and an elbow duct with dimensions X and Y respectively. The first step is to add the external measurements of the two airflow outlets X and Y. From this sum, subtract the measurement A. A is the overall dimension of the finished dynamic branch, to get the intersected size, which then leads to the calculation of dimension C. This measurement C must be divided by 2 and is then called D. Dimension D is then marked on each side of the ducts, which will eventually be joined from the edge of each duct, as shown in the images. It is now necessary to cut by following the line marked on the elbow duct, Y. The dimension on the elbow duct, H, will have to be moved to the line marked on the straight duct, X, and cut at 45 degrees from that final point. Dimension H is quite simply the point at which the two ducts should meet. This intersected area needs to be cut out using the Climova knife or white label tool. The joints are sealed with Climova glue, and then Climova tape is used to overlap the joint to increase its strength. trouser. This assembly separates a single airflow into two airflows. A common name for this assembly is a trouser. Elbows must be constructed on the branches for this duct assembly. The two elbows can have different sections, and the sum of both sections can be greater than the section from the main duct, but the height of the point at which the offset begins must be the same. The assembly principle is the same as that of the simple dynamic branch. It is made from two elbow ducts with dimensions X and Y respectively. The first step is to add the external measurements of the two airflow outlets X and Y. From this sum, subtract the measurement A. A is the overall dimension of the finished dynamic branch, to get the intersected size, which then leads to the calculation of dimension C. This measurement C must be divided by 2 and is then called D. Dimension D is then marked on each side of the ducts, which will eventually be joined from the edge of each duct as shown in the images. It is then necessary to cut following this line marked on both elbow ducts. The joints are sealed with Climova glue, and then Climova tape is used to overlap the joint to increase its strength. Triple dynamic branch. The triple dynamic branch, or three-legged trouser, is a duct assembly that divides the airflow into three. It is made from a straight duct with dimension Z and also two elbow ducts with dimensions X and Y respectively. The first step is to add the external measurements of the three airflow outlets X, Y and Z. The result will be called B. Subtract measurement A from B to get the resulting size, which then leads to the calculation of dimension C. Measurement C must be divided by 4 and is then called D. Dimension D is then marked on each side of the ducts, which will eventually be joined, as shown in the images, from the edge of the two duct elbows and main straight duct. Duct elbows X and Y are then cut following this line. Measurements H1 and H2 are then taken to the line marked on straight duct Z and then cut from this line at 45 degrees from H1 and H2. Dimension D will intersect with the other lines marked H and H2. H and H2 are the points at which the ducts intersect. This intersected area needs to be cut out using the Climova knife or white label tool. The joints are sealed with Climova glue and then Climova tape is used to overlap the joint in order to increase its strength. Reduction to one side, U-shape and a flat piece. This is made using a Climova board. In this example, the aim is to obtain a duct with cross-section C times D from a main duct with original cross-section A times B. When possible, start this assembly with the flat side, which provides a good guide from which to construct the rest. To construct the U-shape, two cuts are made with the red MM tool at distances A and B, measured with the square ruler, as if creating a regular straight duct. Two lines also have to be marked that should be parallel to the ship-lapped ends at distance X on both sides. This may be the same distance or not. On the side of the board that is going to be reduced, a line is traced from the X line to the ship lap at a distance of C plus 1 centimeter. Note, C is the dimension or height at the end of the reduction. Another line is traced of dimension C plus 2 centimeters on the opposite side of the second cut. After the second cut, another line is traced of dimension A plus 2 centimeters to X. To obtain the reductions lid, cut the last piece using the blue tool with dimension B as shown. It needs to be to the side of the U-shape template already cut out. The blue tool is used as it creates the foil flaps through which the two pieces can be stapled together. An internal cut is realized on one side and an external one on the other. This lid will be shorter than the other three. Just cut off what is not necessary. Finally, staple and tape the two pieces together.